In lesson 2, we're going to talk about how to multiply polynomials. So the first thing here is using the distributive property, which you've heard of, you've used when we're just, distributing something through. Now, we actually did it in the last video when we talked about subtracting. We distributed a -1 through. Before we actually go into any problems, let me just refresh your memory. Whenever we multiply, so when we're multiplying monomials, so if I have, let's say, x to the a times x to the b, as long as it's the same base, you're going to keep the base, which is x, and you're going to add the exponents. So this is the rule for multiplying monomials, which is going to be important when we actually get through, when we start multiplying these monomials, when we start applying the distributive property, because you have to keep the base and add the exponents. Now, if you had, let's just say, 2x to the third times 3x to the fourth, what happens with the numbers is the numbers out in front, the coefficients, those are just going to get multiplied because they need to follow the operation. They're just numbers. So 2 times 3 is going to give me 6. I keep the base, and you're going to add the exponent. So we get 3 plus 4 gives me 7. So 6x to the 7 would be the answer for that. So just to kind of show you, you have to make sure that you multiply the numbers in front, keep the base, add the exponent. When we add monomials, so in the previous lesson, we added the coefficients because you're trying to total how many of these like terms do you have, and you keep the base and you keep the exponent. So multiply the exponent, keep the base, but add the exponents. So let's actually go through and start doing some of these multiplying polynomials. So this first one here, we just want to multiply a monomial by a trinomial. So really what this means is you need to apply the distributive property. You need to make sure that this 3x squared gets multiplied by every single piece. So the first thing here is to multiply 3x squared and 2x squared. So again, we multiply the coefficients. So 3 times 2 gives me 6. We're going to keep the base, and we add the exponents. Then if you look at the next term, 3 times 4 gives me 12. Keep the base, and you're going to add the exponents. The exponent of x is just going to be 1. So it's going to be x to the third when I add the squared plus the 1. And then the last term here is just going to be 3 times 5 gives me 15. And it's just going to be x squared. And if you can combine any terms, like if there were any like terms, then we would do that. But in this case, I don't have any like terms because they're all of different powers. So I'm just going to leave it as is, and that's it for that one. So let's try another one. This one here, I want to multiply a binomial times a binomial. Some of you have learned it using FOIL, so you're going to multiply each of the terms. You can also think of this as distributive property. You need to multiply the 3x by each of the terms in the second one, and you need to multiply the -5 by each of the terms in the second polynomial. So it's basically like FOIL. You're doing the first, outer, inner, and last terms. Some of you might have learned it using the box or the rectangle, so I'm going to go ahead and do it that way. I think it's the easiest way to organize the work for this. So what I do is I take 3x minus 5 and I put that as one side of my box. And then I do 2x minus 1 as the other side. And then what happens to fill the box, you're going to multiply each of the terms. So I'm going to do 2x and 3x multiplied together. It's going to give me 6x squared. Multiply the numbers in front, added the exponents. Over here in this box, it's going to be 3x times -1, so it's going to be -3x. Down below, I have -5 times 2x is going to be -10x. And then lastly, -5 times -1 is just going to give me a +5. And then what you do is, now these are my four terms that you would have gotten from FOILing or from distributing, and now it's just combine them. So what I do is, in the diagonal, a lot of times are going to be your like terms, not always, but a lot of times it will occur where the like terms happen to be in the diagonal. So always just check for it. And then when you combine those, we have -10 minus 3x. So you're going to be adding the coefficients. So -10 plus -3 is going to be -13. Keep the x because you're asking for how many total do you have. Well, you have -13 and then +5. And again, if you could simplify this any further, you would, but we actually took care of the like terms right in the rectangle here. So that's it for that. Keep in mind you don't have to use this grid. I just think it makes it easier, especially when you get like a binomial times a trinomial. It's just an easy way to organize your work, but it's up to you if you don't want to do it that way. So let me show you another example. So I'm going to go ahead, I'm going to set up the rectangle again. So I have 2x plus 3, 5x minus 4. Keep in mind it does not matter which binomial you put on what side. It's up to you, it doesn't make any difference. So I just did the 2x plus 3 on the left, and then across the top 5x minus 4. I could have switched these, I'd get the same answer, so it doesn't matter. So I'm going to go ahead and multiply these. 2x plus 5x is going to give me 10x squared. Then I have the -4 times 2, so I get -8x. Down below, I'm going to get 15x when I multiply. And then I multiply and I get -12 when I multiply -4 times 3. Look for the like terms in the diagonal, which I have them. So I get 10x squared. When I do 15x minus 8x, I'm going to subtract the x or the coefficients, so I get +7. And then I keep the x, and then -12 at the end. So that's it for that. So then let's look at one more example. So for this last example here, we have a binomial times a trinomial, which really isn't a big deal. It just means that your initial setup is going to be a little bit differently. So instead of having a square looking rectangle, you're going to have more of a rectangle. So I'm going to have 2x plus 3. I have 2 rows because I have 2 terms, and it just means I'm going to have 3 columns since I have 3 terms in my other polynomial. So keep the negatives with the numbers, and now I can go ahead and I can actually multiply. So I have 2 times 3 is going to give me 6, and you're adding your exponents. So keep the base, add the exponent, so it becomes x to the third. Over here to the right, I have -2 times 2 is going to give me -4. Your exponents, when you add them, will be squared, x squared. +1 times 2x is just going to be 2x. Down below here, I'm going to have 9x squared. Then I'm going to have -6x. When I do -2 times 3 gives me -6. We're going to keep the x. And then the last box here, 3 times 1 is just going to be 3. And remember, you're multiplying to get all of these. And then we're going to check the diagonals. We're going to see if we have any like terms. So in this case, we have like terms here. We have x squareds. And then we also have these terms here that are x's. So we have 2 sets of like terms. So when I rewrite my final answer, it's going to be 6x to the third for the first term. Then I can go ahead and combine the second or the first set of like terms here. So I'm going to have, when I do 9 minus 4, because whenever we add or subtract, we just add or subtract the coefficients. So I have 9 minus 4 gives me 5. Keep the base and the exponent. Then I go on to the next one. -6 plus 2 is going to be -4. And then you're going to keep the base and the exponent, and then your last term here is the plus 3. That's as far as this can get simplified, so that'll be it for that. So again, if you wanted to, if you didn't want to use the box, what you would want to think of when you do this type of problem is to make sure that this 2x gets multiplied by each of these terms. So it's kind of what I'm doing when I'm setting up the box. I'm taking 2x and I'm multiplying it by each of these terms. And then what the next step is to take 3 and multiply it by each of the terms. So then I take 3 and I multiply it by each of the terms. And that's what goes down in here. So the box is just really a way to organize your work and make it seem less complicated because it's all just fitting right in the grid, and that way it's a good way to double check. You really should be getting 6 terms if you're multiplying a 2 by 3. So it's up to you how you want to do it. I recommend doing it this way, but it's really your preference.